In this tutorial, I'll be sharing the multimodular mixed AutoML models, where I have five different tasks under this. So first one is a multimodular text and the beginner multimodular with the net and other things. So here AutoML for image, text, and a tabular, and here it's for a text and tabular, and here it's an entity extraction with a text and image. These three as the one, and the forecasting time series in depth and the forecasting with the chronons. So these are the initial tasks I'll be sharing with the step by step. So here for this one, I'll be using the book price prediction data set from Michael Hack. So this is the data, and first of all, we import all the libraries and other things. So suppose that we import the NumPy and OS to ignore the this stuff for data pre-processing. So here is our data for pricing of books, and we'll be importing this from Michael Machine Hack. And once it's done, then basic pre-processing conversion of text-based reviews and the rating into numerical values are applied in the log transformation of the price. So once it's done, then we go to the training model and other things. So here in the training model, a multi-modular prediction is created, and the model is trained on the subset of the data for around 3 minutes or maybe. So here is a 3 minutes of subset of data will be trained under this. So the initial neural neurons will be automated generated based upon the features, and making the predictions will be the next part. And there we obtain easily performance matrix and evaluation against the true values, and here will be the prediction, and then the future explanation will be in another part where users are encoded to check the other examples and the customization options available for AutoML, and leaving that overall, this is the final embedding as well. In this embedding, we use from the models and demonstrate how exactly the data is done. So it's a overall a combination of text and a tabular as a quick start for under multimodular text. So here for the multimodular text and image, we have other data set we will be using here to handle the multimodal data sets, specifically prediction and the hit adoption and race using images, text, and a tabular data. As a key setup, we need to import all the tools like AutoGluon and PyTorch and the Torch Vision and all. Once it's done, as of for the dataset preparation, the head finder dataset will be used, which includes animal adoption and loaded into the data frames, and image path, and extended for training. As of part of the training a model, we have a set of rules and other things, where for training, for the data training, a multimodal prediction is created and fitted to the training data with a 2 minutes time limit. AutoGluon automatically detects the problem type and the data modulation, select relevant modules, and the training of them. So as a evaluation, the training model performs evaluation on test data using a matrix like ROC and EOC curve, and then we need to make it evaluate and the predictions part. So as a prediction are made on the test data, and the class probabilities are available on the class task. So exact embedding will be done on the tutorial shown on how exactly embeddings are done for the future purpose. So here is the exact embedding thing, and here is a save and load the data. This is also converted into save predictor and the reloading part of it, and the further explanation uses automation explorer and other examples on we can customize our utilities as our HTML examples and other things. Those links are available here. So once this is done, then the a third part is multimodal NER or multimodal entity extraction with the text and image. So this is one of the complex one where we have like using leveraging multimodal data specifically to the text and image as well. So in many applications such as social media and e-commerce, textual context is often accumulated by the images and videos, which can provide a valuable context to the understanding entities. With AutoML, like instead of these modularities in a straightforward, we stand by initializing the autoglone and downloading these data sets, so containing that Twitter data or Instagram or etc. So these data sets included textual snippets of the images. So next we go to the multimodal predictors and other things. So here we have the autoglone installation and the warnings, and the so this will be the Amazon like e-commerce data set. And once the data is done, then we go to the training part and the I mean splitting part of the data. So once it's done, then we train the autoglue on USC, and the time frame will be 300 seconds. So as we create a multimodal predictor named entity recognition NER, we feed the predictor to the training data while splitting the labels columns into entity annotations using allowance of the training a time period or something. So after training, we evaluate the modern test by using such as overall recall precisions or F1 score, etc. For predictions, we can take an input of a sample tweet and its corresponding images, obtaining the features of the entities along with the classifications and other things. The modern ability understanding the context of through the multimodular data. So these demonstrations are done here. As in a part of it, like everything. Here is a prediction section and everything will be placed here. So this is all about the multimodular text with entity extractions of a text and image. So these convenience and its completion of multimodular mixture. Next we go for the time series data. So for time series data, we have two different series data like in-depth and chronos. So I'll quickly go in depth and explain about the few points. So this document provides an in-depth tutorial on the series forecasting using the autogluons and the machine learning toolkit. So here are the consequence summaries of about the probabilistic time series forecasting is a goal to predict the future values based upon the past observations, the ability to generate a mean and quarter line forecasting. So data handling autoglue supports information like a statistic features like a location attributes and other things like the time varying coverages like a holiday and promotions, etc. So for the forecasting model, autoglue offers a local model that is ESA, ETS auto, RMEA, and global module like DPR and temporary fusion transforms. And these are all the examples of that, and forecasting accurately evident using like a maze model. Maze back testing with a multiple windows provided with a more accurate performance estimated. So here is the data for it, and a prediction forecasting time series and additional information will be here. So here we use a UV faster installation so that it can start the information. And here is the ignoration part, and here is the pandas PD read and other things. So once the data read is completed, then we go for time various covariation, and here is the forecasting or horizon, and some other past covariance in the target time series, and known covariations of the test data will be promoted here. And these are about the predictors. So once the evaluation is done, then the forecasting accurately evaluated using a matrix like a mass. So it's a backtesting multiple advanced features, and advanced features where we can perform hyperparameter tuning and handle the irregular data or on missing values. Autoglue automatically adjust these kind of during the training and prediction point of view. So here is holidays example, and once how it's done. Or data formats is time series procure like these are the example data types like time series can handle well. And here is example of training and the test data features. And here is a prediction part. Once the prediction part is done, then original time series and validations splits will be performed in this way. And this is about all about the predictions, autogluons and other things. like here is a model tool and hitting model and other things. So at the last part here we have forecasting with the chronos on using autoglue time series to discuss this how they leverage the chronozone forecasting model in autoglue time series AGTS for the series predictions. So chronozone's models is based on a TFI architecture utilizing a language model by techniques by quartizing time series data into the bucket treated as tokens. This also affect the training in the both in real and the synthetic time series data, enhancing predictions accurately upon the time series predictor API. In our implementation, we can state by initializing the necessary packages and loading the data sets from the AutoML. Once the data sets is loaded, then we fit our model into the Chronoston tiny facets which allows quick training and efficient predictions, which we visualize these predictions in a selected time series. So here is the both part as the predictions and other things, visualization of that pip install optimum, and so here is the entire time series prediction part and the prediction score of the training data. So once it's all done, then at the final the future optimization of the done can be this approach examples the power of a combination advanced modern technologies with user friendly APIs to tackle complex forecasting tasks. So these are the advantages of this using AutoML and other things. So it covers all five different modules. So here it's done. Thank you.